Thank you all. Thank you all. I kindly request Dr. Prahas Amin, Professor, Mangalore University, to introduce Professor Nagesh HR, who is chairing the keynote session.
Good morning, everyone. So it's my privilege to introduce Dr. Nagesh HR. Dr. Nagesh HR is the principal and professor in the Department of Computer Science and Engineering at Canara Engineering College, Mangalore. He has obtained his BTech from NMMIT NITTE and MTech and PhD from NIT, National Institute of Technology, Karnataka, Surathkal, in the Department of Computer Science and Engineering. He has got more than 28 years of experience in the field of teaching and research. His subjects of interest are computer networks, distributed computing, cloud computing, big data analytics, cryptography, network security, systems programming, object-oriented programming, and many more. He has published more than 96 research papers in national and international conferences and journals. He has filed 5 Indian patents. He has delivered more than 40 invited talks. He has also chaired many sessions in international and national level conferences. He had also worked as a visiting faculty to National Institute of Technology, Karnataka, Surathkal, and NITK Science and Technology Entrepreneurs Park, Karnataka, Surathkal. He has published two books titled Fundamentals of CMOS VLSI Design for 5th semester Electronics and Communication Engineering students of VTU, that's with Pearson Education, and VLSI Design for 5th semester Electronics and Communication Engineering students of JNTU, Pearson Education. He's worked as a member of BOE for UG studies in computer science and engineering at VTU Belagavi for the academic years 2011-12 and 15-16. He's worked as a member of BOS in computer science and engineering at VTU Belagavi for the year 2013 to 2016. He has guided 10 PhD scholars and currently he is guiding 6 PhD scholars, and the Vision Group on Science and Technology, VGST, Department of Information and Technology, Biotechnology and Science and Technology, Government of Karnataka, has funded 40 lakhs for his research project, which is titled Technology Aided Agriculture Optimization. VTU has sanctioned rupees 4.4 lakhs for the research project titled Design and Implementation of Security Solution for Healthcare Systems under VTU Research Grant Scheme 2021 for the academic year 21-22. He has served in various reputed institutions as Vice Principal, Dean Academics, Dean Faculty, Dean Examinations, and Head of the Department from August 2007 to 2003. So it's my privilege to welcome you, sir.
Thank you, Press. Thank you, Press, for the nice introduction. Good morning, everybody. I take this opportunity to introduce the speaker of the day, Professor Dr. Mohammad Samiruddin Khan, Pro Vice Chancellor, Engineering, Dean School of Computer Science and Engineering and School of Information Science. Professor Khan stands as a beacon of academic distinction and visionary leadership within higher education, currently pursuing a postdoctoral fellowship at City University of London. His illustrious academic journey is underpinned by PhD in Computer Science and Engineering, an MTech and BE, each testament to his relentless pursuit of scholarly excellence and innovation. Within 30 years of experience, Professor Khan is a prominent leader in academic and research innovation, as Vice Chancellor, Engineering and Dean of School of Computer Science and Engineering and School of Information Science at Presidency University. He drives transformative initiatives that elevate educational standards and research excellence. His previous roles as Director and Executive Director highlight his success in enhancing educational quality and pioneering research. His leadership has secured prestigious accreditations and established key partnerships with major technology companies, including Microsoft and Amazon. Dr. Samir Khan, in fact, extends beyond his administrative roles. He is an esteemed advisory member of Academic Leadership Council UK, a senior member of the Government Council for Higher Education at IST and a distinguished member of Academic Advisory Board of Idea Labs Hyderabad. His contributions to the field have been recognized with prestigious honors such as the APJ Kalam Excellence Award and the Teaching Excellence Award, reflecting his profound influence on education. Embracing the belief that the best way to predict the future is to create it, Professor Khan embodies a forward-thinking commitment to educational advancement and innovation. Through his visionary leadership and strategic collaborations, he continues to shape the future of higher education. With hello, hello, am I audible?
Yes, sir, you're audible.
So, with this brief introduction, I present before you Professor Mohammad Samiruddin Khan, Pro-Vice Chancellor of Prestige University, for delivering a keynote address on AI for real-world impact, ethical challenges and opportunities in computer vision. Over to you, sir.
Thank you, Professor Nagesh HR, sir. We truly appreciate your warm welcome, introduction, and thoughtful insights.
Thank you very much.
With utmost humility, I extend welcome to our keynote speaker for this session, Dr. Samiruddin Khan, who serves as Pro Vice Chancellor and Dean, School of Computer Science and Engineering and Information Science at Presidency University, Bengaluru. Today, Dr. Samiruddin Khan will be presenting on the topic AI for Real World Impact, Ethical Challenges and Opportunities in Computer Vision. Ladies and gentlemen, please put your hands together to welcome Dr. Samiruddin Khan. I request other dignitaries to kindly occupy the seats in front row.
Yeah, sir. Sound.
diminishing the role of human autonomy and decision making when the machines take over us. This is something which is related with the students because it talks about how the AI will impact the job market. So as I said that, the person sleeping there doesn't know what AI will do to him in tomorrow. He has to wake up and be on par with the technology. Otherwise, he will be very much back. So there'll be shift in the job demand, of course. I think you all agree with this. There are so many new designations coming up, new roles coming up. Even the names were not heard of as of now. People are worried that even the coding jobs may not be there in future because uh, a human being need not do coding also, not to take the pain of coding also, machines will do for him. So the programmer job or the coding job also may not be relevant, and you need to adapt with these changing technologies, and uh, you need to identify where is the skill gap. Are you prepared for the future requirement of the workforce in areas of AI? So there are General Data Protection and California Consumer Privacy Acts, which are regulations basically to deal with data privacy and security. And companies are prioritizing security to prevent data breaches and protect user privacy. Data ethics has become a crucial aspect of AI ethics, and it ensures responsible collection and use of data. So let me talk about the building ethical foundations. First of all, respect for persons. We need to emphasize individual autonomy and informed consent in AI development. Beneficence focuses on avoiding harm to human beings, ensuring AI is used for good and not just for profit. Justice that addresses fairness and equality in AI's impacted society. I have been discussing about automated vehicles, but if you see a particular scenario where you are using a automated car, a self-driven car, and when it bumps into a human being or say meets an accident, who is responsible? Is the owner of the car responsible or the technology responsible? So this is again a concern. So we need to see the cost benefit analysis also, whether we need to only weigh the potential benefits of safer roads against the societal impacts of job displacement is very crucial. So the ethical challenges from bias in data sets to privacy concerns and the need for transparency in AI systems demand our attention and action. So as a researcher and a student, we have the power to shape the future of computers vision, ensuring that it remains a force for good, accessible to all, and free from harm. There's a pressing need to approach this work with integrity, critical thinking, and commitment to fairness. In navigating the ethical implications of our work, let us remember that technology is only good as the principles guiding its development. So, by addressing these challenges, AI systems that are not only intelligent but should also be compassionate and inclusive. So, collaboration is very crucial. Organizations, government, and researchers must come together to establish robust AI ethical frameworks. To conclude, AI offers both great potential and significant challenges. So, by carefully considering ethical implications, we can harness the power of AI to benefit humanity while safeguarding our values. So, lastly, I would like to quote the saying of Alan Turing. I think we have been studying Turing machines. So this is the person who is responsible for it, and he's called the father of computer science. And he said that we can only see a short distance ahead, but we can see plenty there that needs to be done. So this ends my keynote address. I think I have completed half an hour. Thanks to Praveen Raja for pushing me to suicide. Uh, and thank you all for patiently listening to me. Uh, and I thank once again uh, Cardiff Metropolitan University, Mangalore University, and all those organizing team members for making this day possible in Presidency University. Thank you all. God bless you.
Thank you so much, Dr. Samiruddin Khan sir, for your enlightening keynote address. Your insights into the ethical challenges and real-world applications of AI in computer vision has provided us with a great deal of inspiration and food for thought. As we wrap up this segment of ICRAI 2024, let us take a moment to reflect on the immense potential of artificial intelligence and the responsibility we all bear in ensuring its ethical deployment. I take this opportunity to specially thank Professor Chaminda from Cardiff Metropolitan University, UK, Professor Khan, Registrar, Mangalore University, Professor Nagesh HR, Principal, Canara Engineering College, for this opportunity and collaboration. I also extend a heartfelt thanks to our Pro Vice Chancellor and Dean, Dr. Samiruddin Khan, Associate Deans. I'm sorry, sir. Yeah, Dr. Samiruddin Khan, our Dean, Pro Vice Chancellor, Engineering, Dr. Abdul Sharif, Dean, SOE, and also Associate Deans, Dr. Shakira L, Dr. Maithili K. Nair, and Dr. Mahalakshmi, Associate Deans of School of ISC and CSE. Thank you, one and all. And I especially thank Dr. Praveen Raja, sir, who has arranged this. Please stay tuned for the next session lined up as part of ICRAI 2024. Wishing you a productive and insightful day ahead. As we move forward, I kindly request the session chairs Dr. Praveen Raja S., Head of Department, School of CSE, and Dr. Gopal Krishna Sham, Head of Department, School of CSE, to take over the sessions of reviewing the research papers. Thank you. Thank you all for joining the session.
Dr. Praveen, you can start the sessions. Am I audible at President's University?
Hello.
Sir, we are ready.
Dr. Praveen at President's University. Am I audible?
Yes, sir. Audible
Yeah,
only,
please
sir.
start. Please start. We are running out of time.
Yeah.
You have time
Sir,
till
still the
11:15 to
screen
finish
has
6
not
paper
shared, sir.
reviews.
Still the screen has not shared, sir.
Sir, this is Praveen here. We are waiting, sir. The
Yeah, we are
presenters can
waiting for
share
you.
their screen.
We are waiting for you. You have to start, and I think they are online presenters. Will present from their screen.
Yes, sir. The first presenter can share their screen.
Yeah, you can start. Your person can introduce the chairs, and then you can invite the paper presenters to start by sharing their screen.
Who will give the intro, sir? the presenter of the paper can share your screen along with title and details.
Yes, sir. This is Naresh Kumar. I will share the screen.
Yes, sir.
Yes,
Please
sir.
proceed.
Please go ahead. Please go ahead.
Yes, sir. Yes, sir. Just a minute.
Can we?
Sir, good morning, sir. This is Naresh Kumar from Sri Sairam Engineering College, Chennai. Am I audible, sir? Whether my screen is visible?
Yes,
Can I
yes.
go
Your
ahead?
screen is visible and your voice is audible. Please
Thank
go
you, sir.
ahead, sir.
Thank you. Yeah, thank you so much, sir. My project title, that is a paper title is Paddy Disease Classification and Fertilizer Recommendation using Deep Learning. This is one of my PhD thesis work. Totally, I have 4 work. Among that, this is one of the work, and this is my last work. Next month, I will be having my Viva Vice. So before that, as a rehearsal, I like to present this paper in this conference. Will be very useful for my Viva also. And my guide is Dr. G. Geeta, and my support student P. Sangeeta Priya. So now I like to explain about the introduction about for what purpose I have taken this concept in this real world. The very first thing is something about we used to know about machine learning, which is very common. This paddy disease classification. So what kind of error, what kind of thing which is facing by the farmers in real world. So that is what that gives me a good impact to create this project as well as research work in my PhD. So paddy disease classification and fertilizer. I used about one more concept, fertilizer recommendation. So these are the 2 crucial aspects of improving rice crop management. So in my work, I did about the pre-processing techniques as well as extracting the future with several hyperparameter tuning concept also. Then majorly I used to compare with 3 things. One is CNN model as well as VGG19 model as well as DenseNet 121 model. So I like to compare all the 3 with my work. So as I said earlier, this is the main motivation for my research work. One is about I need to do something for the farmers as well as what are the problems they are going to face in the real world and what are the diseases which is going to be happen in the plant and identify the disease. And I want to go for with optimized allocation to give some resource for them as well as some solution for them to prevent this for potential higher yield as well as crop yield to optimize in the real world scenario. So I have taken this concept with 4 surveys. One is something about multi-class paddy disease. In this detection, they used about the normalization concept as well as filtering. They create one framework for pre-processing with the 2 kind of operation. One is smoothing and age detection. The second survey is something about the same concept which used by deep learning classifiers with the different approaches. So in this, they use about some employee techniques for future identification as well as object extraction with thresholding and region growing by using many data sets to reduce the noise in the image. The third survey is something about which is also relevant to my project, which is something about rice plant disease classification, which is using transfer using deep convolutional neural network. One of the papers published in 2021. So it will give a clear pre-process accurate image for the leaf structure. And the final survey, which is something about paddy crop disease prediction. So I used about the prediction concept also. So it will be used for my research work. In this, they used about 3 concepts. One is something about a CLAHD. One is something about contrast limited RFA histogram equalization to give about the statistics. Nowadays, data analytics is very playing a huge role. So I used about this concept by using this research paper. I used about that all the parameters, which is something about accuracy, F1 precision, all those, which is compared with the reference 50. I have taken this concept from this paper. So these are the 4 surveys I have did for this concept. So with this, I have implemented in my proposed methodology also with a few concepts. One is about data collection with huge number of data with the real by taking photos from the farmer, and there are pre-processing, which is nothing but used for efficient processing by CNN. The third one is about model building. I used about some models like DenseNet. So this is the block organization diagram of my research work, which is nothing but the I already explained about the disease data set. So how it is actually happen in each and every plant. So I'm going to take that input, take the data as an input for image pre-processing. In the image pre-processing, I used about various classification, various concepts with resizing, augmentation as well as normalization with scaling. That pre-processed data go for model training as well as classification model with a different kind of CNN model as well as VGG 19 model as well as DenseNet 121 model. So based upon that, which DenseNet 121 gives a good accuracy to identify the disease in the plant. So that I made use for the next concept fertilization recommendation for deployment process. So these are the remaining two concepts which I already explained in the block diagram. One is fertilizer recommendation upon the user identification for future references. And the last one is I deployed the concept by using this model, DenseNet 121 model. So this has been integrated with a TensorFlow-like model into the Anthropic project. And the last one is it will be used for, it is created as an app. So UA deployment, like UA UX as you all know. So it will be give attractive and good environment as well as framework for the user, user friendly to work and to identify the disease which is in the plant. So with this, I have used about the implementation concept, which is about a path to the root folder containing the images. So this will be happen during the pre-processing stage. So that I carried with the three work in this pre-processing. First one is about the resizing concept, which is performed to adjust the dimension of the input data. Meanwhile, the second one is about augmentation, as I explained the block diagram. So which is we can able to see zooming the plant and that leaf, we can able to identify in which area it has been the disease has been spread and what kind of thing is happened, and that will be fitting for training the model. That will be very efficient for the user. And the final is about the normalization to apply the scale values of the data. So these are the one of the implementation model. So this is the thing I just mentioned as a pseudocode. So in this the resize image, which is used for this pre-processing. So for each and every image, it will be having one condition, and that is used to resize, and we can zoom by using a model. So the next one is I use about the deep learning models. The first one is CNN model, convolutional neural network. So in that I used some command, I execute and I got the process for the trained model. So these are the different models are there, various positions of the tree, and I used about this ReLU also. The next one is about the standardized VGG 19 model, which is about visual geometry group 19 model input, and I use this also for the classification task. That is one of the major thing which is reowned for the effectiveness. So this architecture which compromises convolutional 2D layers. So we can see about this with max pool 2D layers. That has been good. That has been very efficient for partial as well as downsampling concept. So this architecture is well suited compared to CNN model for multi-class classification tasks, where the output layers activation functions probability across multiple classes. And this is also some of the code I like to disseminate to all the reviewers. So in this, actually it is a VGG 19 model, which is taken from the CNN model input. What are the drawbacks I have faced in that? So that has been model input with pre-processed images, and these are the four structures for paddy classification. And the next one is what I like to go for with the experimental result. These are the stages we can able to see for rice growth stage classification. The first one is normally it's a dry land, and then we have to go for the flooding, that we can save the water, land preparation. Likewise, we can go for vegetative, reproductive, ripening, and harvested. So these are all the basic classification stage that each and everyone should know for paddy classification. So here, just I like to show definitely about a few images. how the disease has been identified in the plant by using about this image augmentation in the pre-processing. So I have given about some images from three different plants. So these are the experimental results I have compared with the three models. One is CNN, VGG19 model, and decimal model. So I have applied all the three models with the with this deep learning. I have identified the accuracy and precision recall and F1 score. Meanwhile, I have disseminated in the graph statistical way with the training and validation accuracy as well as training and validation loss. What are the problems which has been faced and why it came for why it's showing less accuracy for each and every model that has been disseminated also. So by seeing this, the result shows very clearly that DenseNet 120 model will give good result for this particular paddy classification. So this is what my conclusion that 97% of accuracy rate has been achieved more impressive, which demonstrate very clearly about this types of dry air. It's not only just I have started with paddy classification to identify the disease in the plant. So this gives a good outcome that potentially highlights the potential of employing deep learning algorithm by using the model like DenseNet 121. So this DenseNet 121 will be usually densely connected conventional levels of the network and variety. So these are the references from 23 from last year. I have taken 23 as I already mentioned in the literature survey. So I like to disseminate a few of the papers in this references. So this is a presentation from my side.
Yeah, Mr. Naresh, good. We
sir.
understand that this is a part of your doctoral work, right? And you are
Yes, sir. Yes,
about to defend. So, a nice presentation.
Thank you so
Some
much, sir.
queries that may help you, to face that defense of
Viva,
your PhD.
Viva, sir.
Yeah,
Yes,
yeah. In
definitely,
a
sir.
confident way. Yeah. So you have compared your proposed work with the existing works, right?
Yes, sir. Yes, sir.
Your DenseNet thing you have compared with CNN and that VGGNet.
VGG 19. Yes, sir.
Yeah. So one simple query is that why you think that your model is superior compared to the existing ones? What is it that you have contributed? What is the novelty of your work which stands apart compared to the existing works?
Yes, sir. Fine, sir. Why I go for with this model? It's very clear. Whenever we are going to train the label data sets for the LC with diseased plant. Okay, so if you take about each and every plant, some part of the plant leaf will be healthy and some of the part will be diseased. Okay, so if you go for these two models, earlier model like CNN and VGG19 model, the concept, the layers, how to say, the potential of the potential of identifying the plant disease will be somewhat lagging in the leverage concept. So in this way, I go for this, and in this Junction 121, it is very clear and it gives good impact to identify the futures, as well as for identifying which kind of bacterial blight, rice blast, or brown spot, and it is used for many applications also. So these kind of troubles will be happen because of this that can be identified by this DenseNet 121 because of that ability.
Okay, so Naresh, do you mean that the features that you are looking for, they are more, appropriate and accurate compared to the existing research?
Obviously, sir.
So can we know what the attributes of the data set that you have? What are some of the attributes in your data set?
Some of the attributes means actually I used about two kind of modeling processes. One is something but your attribute means depends upon the plant first. What are the things?
Yes. So you have the data set, right? So what kind of values do you have in that?
Attributes we have about that the size of the plant first, actually size of the leaf.
Size. Okay, size is one. Size is one. Then what about other attributes?
Then other attribute is nothing but I have about the range, sir. Actually, the range of the particular place of the plant, particular place of the leaf, sir. For example, if
Okay.
100%, if only if we are having about the
Okay, got it, got it.
growth rate,
So how many such attributes are there, Mr. Naresh?
nearly 10, sir. 10 attributes
10
are there.
attributes. Oh,
10, yes, sir.
okay. Thank you, Mr. Naresh. I mean, you have answered our queries satisfactorily, so there is no problem,
Thank,
right? Any other queries from our other viewers will be there.
yeah,
Yeah,
okay.
very good presentation, Mr. Naresh. Could you go
Thank you so
back
much.
your slides? Could you go back your
Yes, sir.
slides
Yes, sir.
before thank you? Yeah, go back. Yeah, hold on your experimental results, sir. Next slide. Next slide. Next slide. Yeah. Yes. Okay.
It's proposed.
So here you are mentioning that your DenseNet 121 model
Yes, sir.
provides the better accuracy, precision, recall, FN score comparing to your compared models like CNN and VGG19.
Yes, sir.
Okay, how many images you have taken for training and testing, sir?
226 images, sir.
Okay, so
Where
the data set is available to the people, or you have specially made some request and you have collected the data?
actually I went for field visit for many places, sir.
Okay,
So from there I have collected, sir. I didn't collect from Kabul or anywhere. I
so
straight away
these
went
data
for,
are real data collected by you only. Not you
yes,
have
sir. Yes.
not used any data sets.
No, sir. No.
How you managed the memory size, because you may collected the data with good pixels, right? Then how you manage this memory things while training and testing? If 226 images, if you are using for training purpose, and how many images you have used for testing, how you managed this computation time?
Actually, I have divided, sir. If you see about the 226 images, the repeated plans will be, the repeated leaf will be come again with several places. Okay. So I have first segregated with the three phases. So like 70 images belongs to this agriculture purpose, and remaining will be belongs to that particular purpose. So from that, among the 70, I merged by using one app which is called as Tesseract app will be there. Sir. Tesseract model will be there. One concept I didn't explain. So with that, it will merge with a particular leaf. So among that, I can able to go for this accuracy rate.
Okay, so based on that, you have you received this accuracy, precision, recall, and FN score. Okay.
I gave that as a pre-process for segmentation for this model, and that based upon that, it gave the accuracy and precision recall F1.
So this DenseNet 121 has been used by any other researcher for any other purpose, or you have proposed this DenseNet 121?
I have proposed this
Especially for the paddy leaves, I'm asking. You only
for,
proposed this first time
yes,
for
sir,
DenseNet 121.
for paddy classification. Yes, sir.
Okay, then it's very good. Okay. So maybe this work can be converted as a mobile application, and it can be given to the farmers so that they may able to identify the diseases, right?
Definitely, sir. That's why we used for UA UX deployment also. It will be in once I complete my PhD, it will be released as a app, and they can use this also. Sir. I have applied
Sure.
for patent also.
Okay. Wish you all the best, sir. Thank you.
Thank you so much, sir. Thank you, sir. Shall I quit,
Thank
sir?
you,
Shall
sir.
I leave?
You can leave now. Another presenters. Second presenter can share the screen. Paper ID 015. Name of the
Yes, sir.
presenter is Jeevita. Yeah. Now you can
Yes.
share your screen. From Periyar University, Tamil Nadu. Yeah, Naresh Kumar
Yes,
sir,
sir.
you can sign off. Yeah.
Sir, visible, sir?
Yes, madam, you can go ahead. Yeah. You can go for slideshow.
Yes, sir. I am Jivita. PhD thesis, Scholar Department of Computer Science, Periyar University, Salem, Tamil Nadu, India. My title is Fuzzy Low Fast Filtering Approach for Mammogram Image Enhancement for Breast Cancer Identification. Introduction. Breast cancer is an epidemic fatal disease in humans globally, and early reduction is critical for effective therapy and recovery. The main diagnostic method for screening is mammography. Through his radiology find is challenging to distinguish between benign and malignant tumors due to noise and abnormalities in images. Innovative and image processing as methods such as frequency domain filtering must be used in image quality of mammogram images in order to increase their diagnostic reliability. In general, breast cancer is still primary trigger of death from is cancer among women. When mammogram assisted early identification has been demonstrated to greatly increase the likelihood for survival. The study finding for demonstrates how well diffuser function in maintaining important characteristic for lowering the noise for better outcomes of mammogram image enhancement for breast cancer identification. And motivation. Research targets in mammogram images might vary based on study unique method include using the Gaussian and fuzzy low-pass filtering approach for mammogram image enhancement for diagnostic health or decision aids. The goal of the assessing tumor characteristic of tumors for benign and malignant and normal for image identification for benign or normal tumors and malignant is a cancerous tumors for identification for a critical stage for mammogram image enhancement of breast cancer identification. Lack of usual healthcare providers and lack of recommendation from a healthcare provider and a low education level and lack of knowledge of breast cancer risk screening methods. Related works, Srinivasan et al. 2006 is found so Gaussian low-pass filters reduce noise in mammogram images but may reduce fine details for adjusting adaptive filters and techniques for early breast cancer identification. So here that 2015
Devika, madam,
explored. Yes, sir.
You can go to your proposed work, related works
Yes,
and
sir.
all. Okay. Is there any inferences from your related works? You can discuss the inferences. If you have not prepared any slide for inferences, you can move to your proposed work. No need to
Yes, sir.
read all the
Thanks, sir.
authors and their contributions. Yeah.
Yes, sir. Yes, sir.
Move to the next slide.
Yes, sir. Diagrammatic representation, sir. Is a diagrammatic representation for input images and get spatial and frequency domain for fast Fourier transform and filtering applies for existing and proposed one is to existing one is Gaussian low-pass filtering and the proposed method for fuzzy low-pass filtering. So inverse Fourier transform processed the images and get the output of Gaussian low-pass filtering and fuzzy low-pass filtering. Figure 1 illustration for existing and proposed methodologies for frequency domain filters. And proposed methodology is a proposed methodology for the two types and Gaussian low-pass filtering and fuzzy low-pass filtering. Gaussian low-pass filtering for get the images for black images, for fuzzy low-pass filtering for good images for preserving the edges and having the uncertainty more effectively. And characteristics for Gaussian low-pass filter and fuzzy low-pass filter for method smoothing and noise handling and edge preservation and computational complexity and flexibility. Flexibility is less flexible and fuzzy is more flexible and adapts local image characteristics. Experimental result. Gaussian low-pass filtering in mammogram images, a fast Fourier transform are without shifting and with shifting for the mammogram images and get for integration implication of frequency domain representation ring the Gaussian to the observe image to image figure 2, figure 3, figure 4, figure 5, figure 6 and shown the original images and get fixed for Fourier transform without shift and with the shift after the Gaussian low-pass filtering is ring effect for low so 2D wave and surface plot Gaussian low-pass filtering is 3D wave and get the result of the output images for Gaussian low-pass filtering. And the next fuzzy low-pass filtering in mammogram images. Fuzzy low-pass filtering in mammogram images also and also Gaussian low-pass filtering and same for the fuzzy low-pass filtering. But image enhancement is better image enhancement for breast cancer identification to the fuzzy low-pass filtering. Figure 7 and figure 8, figure 9, 10 and 11. Also the same original images and then get Fourier transform without shift and with shift and fuzzy low-pass filtering for 2D weave and 3D weave for surface plot for fuzzy low-pass filtering and get the images for fuzzy low-pass filtering. And the next, the result and discussion for Gaussian low-pass filtering and fuzzy low-pass filtering. So table 1, statistical measure for Gaussian low-pass filtering mammogram images and image taken to 1 to 5. Gaussian low-pass filtering for this PSNR, SNR, MSC, entropy, correlation coefficient index, and the SSIM for structural similarity index measure, and Curtis's skewness, variance, and standard deviation mean. Table 2 also fuzzy low-pass filtering. The comparison of the two result is better outcomes for this fuzzy low-pass filtering. And performance evaluation of Gaussian and fuzzy low-pass filtering is the figure 12 and figure 3. The comparison for better outcomes for the breast cancer identification and then measurement, statistical measurements, and also fuzzy low-pass filtering is best one for this novel methods. The conclusion of this notion of medical image analysis refers to the mammographic images is a pre-processed for Gaussian and fuzzy low-pass filtering. Fuzzy low-pass filtering is better outcomes for the statistical measurements and improve further outcomes of these better images. I taken the reference paper. Thanking you.
Jivita ma'am, thank you. Good presentation. Can we see the reference slide once again, ma'am?
Yes, sir.
We just want to, ensure that you have included
Yes,
the
sir.
recent.
Yes, sir. Once again, sir. I share my screen, sir.
Yeah, go to the last slide, ma'am.
Yes, sir. Yes, sir.
Okay, so the first one is 2006 paper. Next one 2015, 17, 10. Okay, the last one is the very recent paper that you have only published, right?
Yes, sir.
Is it a Scopus Index journal? The last
No, sir.
publication.
Yes, sir. Cross-reference journal publication, sir.
What is the impact factor of that journal?
Sir, this journal, sir?
Yeah, the one that you have published, ma'am. The seventh reference.
Yes, sir.
Yeah, the International Research Journal on Advanced Engineering Hub.
Yes, sir. Yes, sir. Sir, Google Scholar Index, sir. Google Scholar.
Okay.
Yes, sir. Only the Google Scholar, sir.
Right. Okay, ma'am. So one suggestion is that you can just refer some other articles which are recently indexed in good indexing bodies
sir.
like SCI, Web of Science.
Yes, sir. Yes, sir.
Scopus. Yeah. So go to the slide where you have compared your work with the existing research, ma'am.
Sir, go to existing one, sir.
Yeah, comparative
Yes,
analysis. Yeah. Okay. Go to the table itself. No problem.
Yes, sir. Yes, sir.
Go to the results comparison, ma. Jivita, go to the results comparison table.
Yes, sir.
Yeah. Please hold on.
Okay. Now, which is your work, ma'am, in this? Your two tables, table 1 and table 2.
Sir,
table 1.
two tables also my work, sir.
Okay, your work only. So, have you compared your work with the existing research, ma'am? Or is it
sir,
talking
existing
only about
means?
your work?
Yes, sir.
Existing means in the literature survey you have talked about some other authors. They have done some work, right? So
Yes, sir.
compared to their work, where your work stands, whether it is better than that, or whether it is performing in the same way as that work, or whether it is inferior. I mean, maybe not as good as those work.
Yes, sir.
So what
Sir,
is your claim?
Sir, Gaussian low-pass filtering already, so frequency domain filters for Gaussian low-pass filtering and band-pass and high-pass low-pass filtering for the techniques, sir. Gaussians are benchmark filtering techniques and fuzzy is a novel method, sir.
Okay, what you are saying is your proposed technique is novel compared to that, right?
Yes, sir.
Okay, so what are the different parameters that you have compared? PSNR, SNR, MSC, entropy. So whether all the values that you are getting is better than the existing work, or you have some parameter where it actually is on the same
Sir,
frequency or
some similar methods are comparing to this better results, sir.
because I can see most of the values same only, very
Yes,
similar.
sir. Yes, sir. But light changes, sir. Similar changes, sir.
Okay.
Sir.
Okay, so I would just suggest you to look into the recent references, ma'am, from
Yes, sir.
good journal, right? Otherwise, it's a good work. No problem. Thank you. Thank you.
Thank you, sir. Thank you, sir. Thank you very much, sir.
Anything else? Okay, you can leave. Next presenter can share your screen.
Sir, is my screen visible?
Yes, ma'am. Yes, ma'am. Yes, madam. Visible. Yeah.
Yeah. A very good morning to one and all present here. Myself, Sandhya. I am research scholar under the guidance of Dr. Samiruddin Khan sir at Presidency University. The title of my paper is A Comprehensive Review of Representation Learning Models for Pulmonary Nodule Extraction in Lung Cancer Diagnosis. I'm currently working on machine learning and deep learning applications, and this is my survey paper that I've started my research with. So before starting my presentation, I would like to give a brief introduction about the background of lung cancer. As we all know, cancer is one of the most dangerous disease ever known to human because it is very complicated to detect it at an early stage, and most of the cancer related deaths are due to lung cancer. So the 5 year survival rate for this lung cancer patient is only between 10% to 20%. However, the mortality rate can be reduced if the cancer is diagnosed at an early stage. So these are the contents of my slide. Moving on to introduction, lung cancer usually occurs in both men and women, resulting in unmanageable cell growth. Here the cells divide and it will create multiple copies of themselves. But when the damaged cells start dividing uncontrollably, it will create tumor which will affect other organs to work properly. And it could even create a severe respiratory problem both in inhalation and exhalation of the chest. So cigarette smoking and tobacco smoke are the main contributors of lung cancer. Apart from this, it may be the exposure to radiations or environmental pollutions or second-hand smoking, and even the family history of lung cancer may also cause the disease. And the treatment may include radiations, chemotherapy, immunotherapy. Even if the cancer is at higher risk, then the screening will be suggested. So in India, like lung cancer accounts for 5.9% for all other cancers and 8.1% of all the cancer-related deaths. And these are the symptoms that are related to lung cancer. It may be aching cough, shortness of breath, loss of appetite, bleeding, and many more. There are many different varieties of lung cancer, out of which we mainly focus on two types, that is non-small cell lung cancer and small cell lung cancer. Almost 85% of lung cancer falls under this non-small cell lung cancer, where here the cells of this tumor will be very larger and they grow and spread very slowly. And it usually occurs in the lining of the lungs, that is the cell surfaces or the airways. And coming to the small cell lung cancer, here the cells of this tumor will be very smaller, but they spread very faster throughout the body. And it usually occurs in bronchi, which is located in the center of the lungs. And apart from these two types, there are different varieties. That is lymphomas, where the cancer which will occur in lymph nodes, sarcomas, where the cancer will occur in soft tissues. But I mainly focus on this non-small cell lung cancer and small cell lung cancer. The healthcare providers use different diagnosis methods, like it may be imaging test which involves CT scan images, X-rays, MRIs, or it may be the pulmonary testing which involves breathing in and breathing out through a tube to measure the airflow, and even it may be the biopsy where we will remove a small tissue from our lungs and it will be examined under microscope. So once the diagnosis is done, the healthcare providers try to determine the cancer stage, that is how much the cancer has been spread throughout the body. And here the stage staging is a numerical value that ranges from 0 to 4, where stage 0 is the initial stage where the tumor will be created at the top lining of the lungs, but it will not spread to other parts of the lungs. And coming to this stage 1, the tumor will start spreading to the other nodules within the lungs. And in stage 2, your more than one tumor will be created and it will spread within the same lobe of the lung. And coming to the stage 3, more than one tumor will be created, but it will spread to different lobes of the same lung. And coming to the final stage, that is the stage 4, here the cancer will spread to the different lung and even to the different organs within the body. So these are the different stages. So several screening trials have been established in many countries in order to improve the early detection of lung cancer, which results in numerous scans, which has to be evaluated, which is labor intensive. And on the other hand, if the lung cancer is diagnosed early using screening, the clinical response may vary between the patients. And CT scan images plays a major role in lung cancer prediction, because it can detect even the small tumors in the organs, and it provides the 360-degree view of the lungs. However, this CT scan images, they have very low resolution and noisy, which would be very difficult to detect through our naked eyes, and even through the traditional image processing techniques. Although high-tech medical facilities and efficient medical treatments are available, the death rates are not yet properly monitored. Billions of dollars have been spent on the research of this lung cancer, which remains to be an unanswered mystery that needs to be solved. So we have the deep learning is an advancement in AI that allows the computer systems to learn multi-level characteristics directly from the data. And one of the most important deep learning architecture is CNN, that is convolutional neural networks, which uses the convolutional operations in order to extract the spatial features and relationship between the objects. So in recent years, CNN has played a major role in medical image analysis, especially in case of lung cancer. The main motivation of this research work is the trust in referring physicians. Most of the participants indicated that they were not aware of the availability of lung cancer screening prior to discussion with their clinicians. So therefore, referring the clinicians encourage participants to consider screening for lung cancer. The second motivation was early detection benefit. The majority of participants described detection of early stage lung cancer as a major motivation, because early detection would have more treatment options and survival prognosis, which is more favorable than advanced stage. And the third was perception of low or limited harm. The participants primarily discussed about the radiation exposures, which leads to potential harm of LD-CT scans. But however, 63% of participants, they have noted that lower radiation dose were involved in the LD-CT screening versus other screening. That motivated them to pursue screening. And finally, the final motivation is through friends or family with the advanced cancer. Several participants described their family members and family experiences, friends' experiences with advanced cancer as a motivation to take care of their own health and participate in lung cancer screening. So these are the different motivations for the research work. Moving on to related work, I've categorized my research. I've done survey for the last 4 years, that is from 2023 till 2019, and these are the related work. And I have created a PPT with the inferences out of all these references, and I've categorized this into three sections. That is the survey on nodule detection. The very first, I focused on detecting the nodule, and I have referred all these papers, and these are the authors. They have used different models and they have used different accuracies. And I have done a survey on segmentation, that is nodule detection using segmentation. And finally, after the nodule detection, I have classified the survey into the different classification. That is to classify whether the nodule is cancerous or non-cancerous, that is malignous or non-malignous. So this is the analysis I have done. So as per my analysis on the nodule detection, co-learning feature fusion CNN is providing the highest accuracy of 98.7% on nodule detection. And coming to the segmentation, UNET is providing the highest accuracy, that is of 98.94 percentage. And coming to the papers that I've reviewed on classification, CNN is providing the highest accuracy, that is 98.7%. So coming to this inferences, as per my observation, these are the inferences I've noted from the survey or the references I've referred. So the very first thing is the significant challenge in lung cancer research is using DL is the lack of large and consistent labeled data set. So most of the authors have worked on small data set, where working on the large data set is the major challenge, and having the labeled data set is one more challenge, that is the availability of large inconsistent labeling of the data set. And coming to the second point, we have used CNNs. As per my previous analysis, CNN, all the algorithms under CNN is providing the better result. So DL models, especially the CNNs, have the ability to automatically extract the features, which will be reducing the computation power even, and it will be extract the features from the images without needing any manual feature extraction, any manual feature engineering. And coming to the third point, most of the existing models are optimized for identifying the late stage tumors. However, there is a need to improve early stage detection of small nodules, which remains an area in the research which needs to be addressed. And coming to the fourth point, research is required to develop models that can predict the clinical outcomes, such as how a patient will respond to a treatment or their survival rates. And somewhere I felt the efficiency and the accuracy can further be improved by using some other ensemble learning or combining, going with the hybrid CNN models. So moving on to the conclusion from my review, this research gives a summary of current development in the lung nodule segmentation, detection, as well as the classification using various deep learning models. And within this deep learning model, CNN have gained a prominence among the other methods as a key deep learning technology. And finally, as I've already discussed, CT scan images plays a major role. So I will be using the CT image data sets, which are common source for training the different networks. So these are the references I've included. Thank you.
Yeah, very good presentation given by Sandhya, madam.
Thank you, sir.
Yeah, we have seen a detailed literature survey of your articles. I hope, based on the inferences of your literature, have you proposed any methods?
Sir, I've just started my work, sir.
Okay, but
I'm going with Ansible.
have you identified the proposed architecture based on your inferences from the literature survey?
Yes, sir. I've just started with the CNN model. I'm trying to go with the hybrid model, combining different models, and I've
Okay.
just started with the implementation part.
Okay. 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 Go ahead.
Yes.
Okay. Thank you.
Thank you, sir. Thank you.
Now you can leave. The next presenter
Yes,
can
sir.
share your screen.
Yeah, sure.
Yeah, your screen is visible. Go ahead with your PPT, ma'am.
Just a minute, sir.
Yeah, yeah.
Am I audible, sir?
Yes, yes, you are audible. Share your PPT.
Good morning, everyone. I'm Bhuneshwari Patil, and my research is in soft biometric. And as part of my research, I'm here to present on facial texture features for age classification.
Before going for the main content that is about the textures, I just want to brief about the background. As we know, biometrics, generally we are considering the hard biometric where we are involving ourselves to give the inputs like the thumbprint or the iris scan or the face scan and all. But generally, these scanning biometrics needs an additional hardware devices which will impact the cost. These are high in cost, and other than that, the user involvement is required. Whereas my research is on soft biometric, where the user involvement is very minimum. Uh, and these are the few biometric features like finger, hand, iris, face, DNA. These are the psychological feature, and the behavioral features like keystroke, the way the person type or the way the person walk. All these are the behavioral features. What actually the soft biometric is? Initially, it was introduced by Alphonse Bertillon in 19th century. He was an police officer. He used to identify the criminals based on their behaviors. Means like
Madam,
the
please go
size of
ahead with your proposed work, madam. Introduction part is okay, biometrics types and all is okay. Go for your
sir.
objective and proposed architecture diagrams. You can
Yes,
explain
sir.
more your proposed method.
Actually, yes, sir. The motivation for the work is non-intrusiveness, like the involvement of the user is not required. And as there is no involvement of the additional hardware, it is cost effective and reduced privacy concern because it is not individual. These are little general as compared to the hard biometric, and it is user convenience because whenever the user is available, the data can be extracted. These are the few existing work which I have considered. Mainly texture based feature. Here the author has considered the age as the regression parameter, but in my case I have considered it as an classification. Why? Because my earlier work where I have used both the regression and classification method, but I observe classification is giving better result as compared to the regression. So future work will be extending this for the regression. So this is the proposed model where the image is captured and the face is extracted using the Haar cascading, and then it is resized. Why? Because as we know, the when we are performing any models, the machine learning models, the image size matters a lot. That's the reason I have considered very small image size, that is 48 cross 48, just to check the performance of the different texture feature models. Then it can be extended to the higher size of the image. So this is the data set what I have considered. Initially, I started with the UTK phase. Why UTK phase? I have done the earlier work on 5 different data sets, publicly available data set, and UTK phase is having minimum noise, and the multiple research work has been done on the data set. I trained the model using UTK phase and then tested on the data set which is collected with the help of students. The feature extraction, the local binary pattern, global Gabor feature, LPQ, wavelet transform, HOG, and BSIF. These are the few the texture features I have considered. Where multiple research has done separately, so I thought let me combine all those and check the outcome of this. So this is an way why how we are extracting the LBP features. So by comparing, suppose if we are having the 3 cross 3 filter we are considering, by comparing, just it is a simple comparison. If the pixel value in the surrounding is greater than the center pixel, it is done with the 1. If it is less than the center pixel, then it will be assigned as 0. This is how the binary pattern is created. After the binary pattern creation, it will be converted into decimal. Here one example is shown. The next is the Gabor filter. It is mainly based on the Gaussian filters, and it mainly effective when you are considering the different orientation. For my research, I have considered 30-degree, 45-degree, 60-degree, 0-degree, and 90-degree, because as we can take for the other other three quadrants in the same manner. And the next is the LPQ. In the LPQ, mainly it considered the Fourier transform and the phase angle. Okay, as it is focusing on the phase angle, it suppresses the noise. That is the major advantage of this, and also it captures the phase information. As here we can see the imaginary and the real parameter as the representation is done in the complex representation. And next feature considered is the wavelet transform. Here it is once again the frequency domain texture feature extraction method. The based on the frequency band low 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 high and high low and high high. So based on that, the why we are how it is advantageous means, as in the frequency band, the center that is near to the origin, the more information is will be there, and as we are moving away from the origin, that will be considered as the noise, and this transformation will suppress the noise. So by that we will be getting only the useful information. The next texture feature consider is the histogram of oriented gradient. Here any the edge detection algorithm is used for the small window. This is the locally here I have used 3x3 matrix, convolution matrix, to extract the gradients. Once we are extracting the gradient, here we can see the direction of the edge, the direction in which the edge is generated, and for these edges the histogram will be drawn, and based on the histogram value the final pattern is plotted. This is the output of this texture feature extraction. The next is the binarized statistical image feature. Here the multiple convolution matrix are used and it is moved along the image, and the binary values are extracted. Here the all the bins, the different bins, the statistical parameter, mainly the variance is considered. So based on the variance value, the extracted pixel values are put into different bins. Here I have considered 128 bins for the binarization, and the resulting image is used for the training the model. So this is what the architecture, very simple architecture I have used, as I mentioned in the beginning. So image size is very small. Based on the performance of these texture models, I have planned to use the complex neural network model. Why? Because as we know, the memory and the processing is a very critical objective when we are running any model. So these are the comparisons, I mean the results what I have obtained. One, I have used the different regularization parameter and like early stop and the learning parameter. By default, instead of keeping the learning rate as constant, I have regularized, means based on the performance of the model, the learning rate is reduced, so that reduced or increased depending on the outcome accuracy values. Here we can observe. So out of these six models, LPQ shows better model with and without regularization during the validation. That's the reason I conclude that LPQ, this is the other way of representing the texture features. For the training we observe, all the models are having steady curve, whereas for the validation, we observe that the LPQ and the LPQ and LBP are having stable curve as compared to the other texture features. So these are the few tabular representation of the same what I have shown in the bar chart. and this is the predicted output, and almost all predictions are as per the actual one, but few are differences here. And the final conclusion is that the LPQ shows better outcome for the validation, and the learning rate and the early stop parameters I have considered, which reduce the model training period and also the complexity of the model. So these are the few references which I have considered for. Thank you.
Yeah, very
Any
good
questions, sir?
presentation, Bhuvaneshwari Patel, ma'am. So your proposed method, as per your presentation, your proposed method is LBQ, right?
Yes, sir.
Okay. So
Feature method, sir. Yes, sir.
future extraction method. Okay.
Yes, sir.
So as per your presentation, your results shows that nearly 80 percentage only. Then nobody has proved that the accuracy is more than 90 percentage in the respective identification of age regularization.
Sir, in this, one of the author has achieved, but the image size what I have selected, that is, if you can imagine 48 cross 48, it is too small size as compared to the survey what I have done. Minimum is 128 cross 128 what they have considered. So, but if we, as we know, as the image size increases, the performance, the training of the model and the prediction both will take lot of time. That's the reason I made an attempt just to see for the smaller size how it works.
Okay. So my suggestion in the further results, you can
Yes, sir.
add FAR, FRR, like a false acceptance rate and false rejection rate also in your results.
Yes, sir.
Because I have not seen this FAR and FRR. Even you can add equal error rates also, because sometimes the
Yes, sir.
system may not able to predict the exact ages. So in that time, you could use these parameters: false acceptance rates, rejection rates, and equal error rates. Okay.
Yes, sir. Yes, sir.
Yeah, ma'am. Okay. Thank you, madam.
Thank you, sir.
So the next person can share your screen. The next presenter.
Good morning, sir. Is my screen visible, sir? Am I
Yeah,
audible, sir?
visible. You are audible, but we may not able to see your presentation. PPT is not visible.
Oh, PPT is not visible. I'll try sharing. Is my screen visible, sir?
No, madam. Yeah, now it is visible. Slideshow, madam.
Okay, sure. Uh, Good morning, everyone. My name is Rishi Masu, and I'm currently pursuing MTech in VIT Chennai. This review paper is part of my project under the guidance of Dr. Srikandar. So I'll move on with the presentation. My paper title is on systematic review on machine learning algorithms in image forgery detection. So these are the content of my presentation. Now moving on to the introduction. Today, digital media plays a vital role in our lives. Images and videos are widely used across social platforms for various purposes, including social feeds, evidence,
Madam, go
entertainment,
for slideshow. We may not able to see your presentation. We are not able to see
and
your presentation. Go for slideshow.
uh,
Presentation.
this is
Slideshow presentation.
so this is slideshow, sir.
No, we are not able
I
to
have
see your
started slideshow, sir. Is
presentation.
it? I will stop and share it again.
Once again, you can.
I'll stop sharing again.
Yeah.
Is it visible now? Yes, sir. Is is my slide visible?
No, madam. Yeah, yeah. Now it's visible. Yeah, now it is visible. Now you changed. Before it was visible.
Okay, sir. Is it visible? Sorry, sir. Is it visible now, sir?
Please go ahead. Yeah.
Visible now.
Okay, sir. So I'll start with the introduction. Today, digital media plays a vital role in our lives. Images and videos are widely used across social platforms for various purposes, including social feeds, evidence, entertainment, and news. They have become essential tools for communication and storytelling in our modern society. However, the authenticity of digital content is increasingly threatened due to advanced manipulation tools. These tools contribute to defamation and misinformation and people influence public opinion negatively. So to address this, our work examines and categorizes various image forgery techniques, reviews existing detection methods, and explore machine learning solutions for combating those issues. Now, moving on to motivation, the rapid rise in the use of digital media has posed significant challenges to the content authenticity, like I mentioned earlier, due to the advanced capabilities such as Photoshop, memes, and many
Screen is not
other
visible.
applications.
Slides are not visible.
Sorry,
Slides are not visible.
it's the ultra shadow. Yeah. Is my slide visible now, sir?
Share your window once you run the slideshow.
I start.
In the share selection window, you select the window where you have done the PPT presentation mode.
I have here it's showing screen share. So is it still not visible?
No, not visible.
Madam, take a help of any of your friend, or you can share your entire screen. Share your entire screen. Yeah, go to share window. Go to share option, ma'am.
Yes.
Yeah, your camera is visible now. Now you can share your PPT.
Please. Is it visible next?
No, please hold. Please hold. Wait. It's not visible. Earlier it was, na. Same way you can try.
It's showing,
We can able to see your window. Now you can share. Go to the share button. Nearby leave na.
Yes.
Go to the share button, madam. Now you can open your PPT. No, madam, we are
Is it
not able.
visible, sir?
It's not visible, madam. Not visible.
Can the next presenter start? So
Dr.
till
Praveen,
then, I'll figure out the
Dr.
Yes, sir.
Praveen, you can go to the next presenter. By the time she can
Yes.
prepare her.
Okay, sir.
Yeah. Yes.
Okay.
Yeah. Now
Sorry
it's
for the
visible. Now it's visible. Hold on. Now it's visible. Go to the previous slide. Previous slide. Go to the previous slide, madam. Now we can able to see the introduction slide.
This one. What's this one?
Previous. No.
Think means I'm not able to change
Yeah.
the slide when I click this one.
No. You can leave, ma'am. You can leave. Next presenter can share your screen.
Okay, sir.
You can leave now.
I'll figure out.
Next presenter can share your screen. Next presenter, paper ID 045.
Yeah,
Rupa, madam.
sir, yes, I'm sharing my screen. Is it visible, sir?
Yes, madam. Yeah, your screen is visible. Please go for
Okay.
slideshow, madam. Yeah.
Yeah, is it fine, sir?
Just a minute, madam. Your screen is visible. Go for slideshow.
Yeah, I have put it in slideshow mode, sir. Is it visible?
Okay, go ahead.
Okay. So, good morning, everyone. I'm Rupa Maliekal, and I work in TCS as a responsible AI consultant, and I'm also doing a part-time PhD under the guidance of Professor S. Ashraf in Digital University, Kerala. So, what I'm going to present today is the initial research work that I have done as part of my PhD. My paper title is An Empirical Study on the Impact of Proxy Attributes on Fairness of Machine Learning Systems. So, fairness in machine learning is a much researched area. The research has
Madam,
been
your
happening
slide
for
has
many
not
years.
moved. Your slide has not changed.
Okay, let me try resharing the slides. Is it visible, sir? Are you able to see the introduction slide?
Yes, madam. Yeah.
Okay.
Go for
So,
slideshow. Go for slideshow, madam. Now.
yeah, it is in slideshow mode, sir. I don't.
Okay. Move to the next slide. Move to the next slide.
Are you able to see the introduction continue?
Introduction. No, madam. We are able to see only the introduction slide.
Okay. Let me try to rejoin, sir. Maybe some.
No.
Maybe my.
Don't stop your sharing. 1 second, you can try. Don't leave the meeting now.
Okay. Maybe I'll. Can I turn off my video, sir?
Yeah, ma'am. Yeah.
Okay.
Yeah,
So are
madam,
you
your
seeing
screen
it
is
in slideshow mode?
go to the go to the slideshow, madam.
Yeah, it is in slideshow, sir. Can you see the introduction slide in slideshow mode, sir? Okay.
No, madam.
So can we continue?
No, madam, your first slide is only visible. Yeah. Now you can present in the same way. Don't go for slideshow. Same way you can present.
Okay.
Don't go for slideshow. Yeah.
Okay, sir. Yeah. So, fairness in machine learning is a much researched area, and there have been a lot of research happening since many years. And fairness is usually measured, the outcome fairness is usually measured with respect to what what is called as protected attributes like age, disability, gender, marital status, national origin, race, religion, sexual orientation, and so on. Now, measuring fairness with respect to these protected attributes have been studied a lot, and it is pretty straightforward also. But due to awareness about the impact of such protected attributes and how it can impact the machine learning outcome with respect to fairness, and also to comply with data privacy regulations, now models are getting created without these protected attributes in the feature set. So, like Mr. Srikant Shenai was also mentioning in the keynote address yesterday, in many countries, there are data privacy regulations which regulates the collection and usage of such protected attributes due to privacy issues. But however, even not including these protected attributes in the feature set was also showing or giving discriminatory outcomes in the machine learning.
Go
So
to your
outcomes based
proposed
on machine
work,
learning.
madam. Go to your
Yeah.
proposed
Okay.
work, proposed
Yes.
methodology. Yeah.
Yeah.
Next slide. Yeah.
So, in my proposed methodology, I have followed these 4 steps. First, started with data collection, data preparation, model building, and then measured using some already available fairness metrics. So, what I did was I collected 2 data sets. One is a recruitment data set. This is a synthetically generated data set which I got from Kaggle. It has 13 variables, which of which 3 are numeric, 6 categorical, and 4 binary. And it had 4,000 records, and it had the outcome variable is the recruitment decision, whether the candidate is recruited or selected or not. Now, another is an adult data set. Now, this is taken from US census, and it had 14 variables. So this is a real data set. And out of the 14 variables, 5 are numeric, 9 are categorical. And this had about 32,545 records. Here, the outcome variable is income prediction. So income is greater than or equal to 50K or less than 50K. Now, for data preparation, I removed unique attributes, which was ID from recruitment dataset and final weight from adult dataset. And both these datasets had class imbalance with respect to gender class, with a higher representation for male gender. So I did a downsampling as part of data preparation to balance with respect to the gender class. Now, in model building, what I did was I selected the features from both the recruitment dataset and the adult dataset using mutual information score as the feature selection technique. And then I created models
lecture is Applications of Artificial Intelligence. And the session chair is Dr. Manjaya DH, Senior Professor and Chairman in the Department of PG Studies and Research in Computer Science, Mangalore University. He completed his MTech from National Institute of Technology, Karnataka, Surathkal, and PhD in Advanced Network Computing Paradigm with Quality of Services and Performance Analysis at Mangalore University. He is involved in teaching and research for more than 30 years, and he is the principal investigator and director for 20 core project from the PM Usha Ministry of Education, Government of India for the amplification and development of both research and academic activities in Mangalore University. He has delivered more than 235 invited talks in several international conferences, symposium, workshops, and training sessions in India and abroad. He has authored and published around 167 research papers in reputed international, national journals and conferences on various topics in mobile ad hoc networks, IPv4 and IPv6 mobility, machine learning and deep learning, virtualization using cloud computing, cyber security, and digital forensics. Hearty welcome to you, sir. Now, Professor Manjaya will introduce Professor Niranjan UC, the keynote speaker of the session.
Very good noon to all respected members of this esteemed conference, International Conference on the Responsibility of Artificial Intelligence 2024. Respected members who are all present, we are going for the second day of the keynote talk from the esteemed delegate, a person none other than, we can call it a NUC, a professor, a well advisory and the suggester and the inspirer and as well as the motivator to the electronics department as well as computer science department. Just I would like to just read in between his small resume in front of us. Professor Niranjan UC obtained his Doctor of Philosophy from the Indian of Science in the discipline of electronic science from Bangalore, and professor is well versed with his area of specialization in especially the biomonitoring institute and worked some of the projects from the Japan and during the year 1994-96, and was worked as adjunct professor to the Department of Electronics and Communication, Mangalore University, and as well as Sayadri College of Engineering Management at DR. And professor is is enriched his knowledge, basically the artificial in emerging area, and number of projects he has taken, and also moreover, and he was the alumni, because we are all the alumni of the NITK product only. On behalf of the Mangalore University, on behalf of the ICRAI 2024, I extend a warm welcome to you, Professor. And Professor will go for the keynote talk on the area of the applications of the artificial intelligence, which are well focused for our thoughts. And please kindly listen his talk, and we can go for the queries and the suggestion. And on behalf of the university, plurally welcome. Thank you, and I request all the audience for your kind attention, kind concentration for the keynote talk of Professor NUC.
Good afternoon. The first slide is, I think there is some issue because I use a Linux machine and here it's all Windows, so that's not coming up. It's okay. Professor has already talked about me, and I have been coming to Mangalore University and Department of Electronics for quite some time. Way back from 1999, I met a former student of here. So I basically worked in embedded systems in a company, also in a startup company in Manipal. So my talk is basically tuned to hardware implementation of artificial intelligence. So these days I've been working in the area of artificial intelligence, so I will just touch upon that. But before that, I thought it's relevant to talk to you about the relevance of AI, and also I will be talking mainly about large language models, that is the chat bots and chat GPT, etc., and which I think all the students would know and will be using to submit their essays and things like that, assignments. So this year's Nobel Prize in Physics was awarded to two gentlemen. No doubt they are from physics, and artificial intelligence takes a lot of cues, a lot of inputs from physics, chemistry, and computer science, and so on. So John Hopfield, and I used to teach a paper of John Hopfield, and there is a very famous network of his which is used in AI, and that was what we were talking about earlier. It's called Hopfield network, which is also Hebbian learning, and then that is how the brain works, and then that is how it's called associative memory. And his algorithm was very crucial, and he is basically a physicist, and he has taken the help of physics in order to derive it, that Hopfield network, and also the learning algorithm in Hopfield network. And Jeffrey Hinton is another Canadian professor who has worked in artificial intelligence, and he has got lots of algorithms, especially what is known as Boltzmann algorithm, which tries to capture the various patterns which are there in the data.